In this Key Concepts module, I'm going to talk about epithelial tissue. So epithelial tissues provide surface coverings and internal linings in areas of the body. Epithelial tissue must always be described as the shape of the cell and the number of layers of cells. If you don't include both of those pieces of information anytime we ask you about epithelial tissue in assessment, then you will lose marks. So if we look at the classification of epithelial tissue, it is covering and lining epithelia, and they're classified according to the shape of the cells and how many layers thick they are. So if we look at the arrangement of layers, you can see that they can be simple, so this is one single layer of cells. Pseudostratified, so here you can see that all of the cells actually make contact with the basement membrane, but the nuclei are located at various regions and the cells are squished together, so it looks like there's multiple layers, but there's actually not. And they can be stratified, so you can see here that there's multiple layers of cells in this particular area. Cell shape, we can have squamous epithelial cells, so these are flat cells. And if you have a look at them, you can see that they've got this nucleus that creates a raised area in the cell, and these are often, an easy way to remember them is like a fried egg. Cuboidal epithelial cells, and so these are square-like or cube-shaped in structure, and they have a central nucleus. And columnar epithelial cells, so you'll see that these are taller than they are wide, and they've got basally located nuclei. So where do we find simple squamous epithelium? Well, in the small intestine. So this is a single layer of flat cells. And if you think about the function of the small intestine where we're looking at absorption of nutrients, then it makes sense that there's only a thin layer that these nutrients actually have to pass across. We want the process to be easy so that the maximum amount of nutrition can be absorbed from the small intestine. Simple cuboidal epithelium is found, for example, in the kidneys, and you'll see that here we've got this cube-shaped structure with the centralised nuclei, and you can see that here they're lining the tubules in the kidney. Non-ciliated simple columnar epithelium, so you can see here that these cells have got some projections on the surface of the cell, and it's easier to see in this diagram over here, but these are microvilli, so they're finger-like projections, they're not hairs. So remember, the hairs are the cilia. And so areas where you find these kind of columnar epithelia are areas typically of secretion. So again, in the small intestine, we're looking at absorption and secretion, so we get production of things like mucus. Ciliated simple columnar epithelium, and so here you can see that we have got cilia, and you can see here that they're much, much larger and longer than what the microvilli are, or those hair-like projections. And again, we see these in areas where we want some form of secretion occurring. And so the example that you've got here is from the fallopian tube or the uterine tube. And this is the part of the female reproductive tract that actually transports the egg from the ovary after ovulation towards the endometrium for implantation after fertilisation. So if you think about the function of each of these cells, it's easy to think about what might be located in particular regions in the body. Pseudostratified ciliated columnar epithelium is found in the trachea, and so if you think about what the trachea, the purpose of the trachea is, it's really for the movement of air towards the lungs. We've got ciliated cells in the upper respiratory system structures because we want to be able to trap any particulate matter before it gets to the smaller structures in the lungs. And you can see here that there's also mucus production. So the columnar cells, again, remember, are related to a secretory function. And so we've got mucus production in these upper respiratory system structures to actually trap any particulate matter, and then the cilia will sweep it up and out. Non-keratinized stratified squamous epithelium. So when we're thinking about epithelia that are lining particular areas, it's important to note whether or not they're keratinized or not. So remember, the keratin is that waxy waterproofing protein that we see on our skin, Now, it wouldn't make sense to have that kind of process occurring within the vagina because we want it to be a moist, warm environment, and so we don't have that waxy protein produced by the epithelial cells that line that particular structure. But there's a number of layers of cells there so that it's a protective feature because there can be sort of a little bit of trauma associated with the function of the vagina. Keratinized stratified squamous epithelium is found on the skin that's covering our body, and it forms part of that protective feature. So you can see that these layers of cells on the surface are dead and they've dried out, but we've got, again, multiple layers of flat cells, and so you can see that there's absolutely multiple layers here of flat cells, and again this is related to the function of the skin in that there's going to be a lot of abrasion that occurs in our day-to-day activities. So if we only had a single layer of flat cells on the skin, if we were to rub past something, a doorway or a person, then you'd find that you would have this lesion and you'd be bleeding everywhere. So it's important that we have those multiple layers in areas of the body where you're going to have abrasion occurring. We've got stratified cuboidal epithelium in the esophagus, and so you can see again here these centrally located nuclei, and they're multiple layers, and it's again because when people chew their food they perhaps don't chew it as well as they should, and so the food in the back of your mouth, in association with your teeth and your hard and soft palate and your tongue, is actually balled up into what's called a bolus, and then the bolus is swallowed down the esophagus, and it's sometimes larger than it should be and sometimes not as smooth as it should be if we haven't chewed our food properly or for a sufficient amount of time, and so it's important that we have more than one layer there, again, to prevent trauma to that particular structure. We've got stratified columnar epithelium in the pharynx, and so remember we're thinking columnar because we want some kind of secretory function occurring. So once we start to move down to these structures associated with obviously the digestive system or the respiratory system, we want to be able to trap debris if we're looking at moving towards the trachea, or we want to be able to smooth the movement of this bolus towards the esophagus, and so either way we will need some mucus production. If we look at transitional epithelium, this is really something that's quite unique, and it's found in the urinary bladder, and you'll notice that when the urinary bladder is full, that the cells look quite flat on the apical surface or the top surface. Whereas when the bladder is empty, you'll find that the cells look quite rounded at the apical surface. So this epithelium has the capacity to stretch, if you like, with the changing shape of the organ that it's related to. And so it's a really unique feature of the bladder's epithelium. You can see though that again we're looking at more than one layer of cells, and it's as a protective feature. Glandular epithelium, so this kind of epithelium can be a single cell or a mass of epithelial cells. Their function is related to secretion. So you can have endocrine glands, and so these are going to release contents, things such as hormones, into the bloodstream. Or you can have exocrine glands, and the exocrine glands are going to actually release their contents into the surrounding area. If we look at the skin, you can see here again we've got these cuboidal shaped cells, and there's a number of layers of them, and here we've got an exocrine gland because we know that sweat is actually released to the outside of the skin.